Hello, welcome to our webinar today about air quality and impact assessment. My name is Bridget John and I will be your moderator. Today's webinar is hosted by the International Association for Impact Assessment, or IAIA. We are the leading global forum for advancing best practice and innovation in the field of impact assessment. And we advocate for using impact assessment to improve society and the environment. Today's webinar is part of a series of webinars offered by IAIA, and I invite you to visit our website and check out a few of our recent ones that we have on demand for you. You can see on the screen that they range in topics from gender, emerging technologies, biodiversity, indigenous peoples, health, resettlement, and a wide variety of others. So please go and check out our website. You see the URL there on the bottom of the page, and visit any of them. They're free and available to everyone. If you'd like to follow us on Twitter, you can find us at IAIA Network. And if you'd like to tweet out something that you're learning today, that'd be great. You'll see our webinar hashtag there is hashtag IAIA webinar. We'll jump into a little bit of housekeeping before we get into the main presentation. You'll see on your control panel there for GoToWebinar that there is an orange or red arrow, and that controls your control panel. If it's blocking your screen so that you can't view the slides, that just makes it fly in and out. So you can essentially minimize your control panel by clicking on that arrow. We are recording our webinar today, and you will receive a link to that recording afterwards. Today is a 60-minute webinar, and we are accepting questions. We'll be handling those for the last 20 minutes or so, but please feel free to ask questions anytime throughout the webinar. You'll see in your control panel there's a gray questions pane. So if you open that, you can type in your questions throughout our presentation, and I'll be moderating those and looking through those, and we'll pose those to Franco at the end. The slides are also available to you in the handouts pane of your control panel, and you'll also see there's a link there to download the air quality and impact assessment guide that we'll be covering today. You will also receive a link to the slides when you receive the link to the recording too. So don't worry, you'll get all that information. Our presenter today is Franco DiGiovanni. Franco has an undergraduate degree in geology from the Royal School of Mines at Imperial College, and he has a PhD from the University of Hull in dispersion modeling. Franco completed a postdoctorate at the University of Guelph, and he held a Natural Sciences and Engineering Research Council visiting fellowship at Environment Canada. He has worked for 25 years in regulatory air quality impact assessment in Ontario, throughout Canada, and around the world. And he's a co-author of the document of IAIA's guide that we'll be talking about today. So now I'll turn the presentation over to you, Franco.
Good afternoon, or morning, or evening, wherever you are in the world, and welcome to this presentation. It's very nice of you to attend in these times. Just to get started, I have a little bit about my company on this slide, which I will leave for reference. As Bridget mentioned, IAIA will be providing these slides of the presentation. The agenda is presented on this slide, so after the introductory slides, I'll go through the guide in the approximate order of tasks that one would go through in an air quality impact assessment. The IAIA guide is one of a series of special interest publications. It's a living document, which means that future suggestions and expansions are welcome and will be vetted by the current authors. The guide was developed based on a perceived need to address uncertainties and inappropriate methods that were being practiced. And as such, the intended audience was originally thought to consist of experienced practitioners and regulatory reviewers. However, we may have to rethink this and redefine our audience as all classes of practitioners, as the fundamental concepts described here may be of value to practitioners in all stages of their career. The guide itself is meant to overlay jurisdictional regulatory advice, not replace it. In other words, the guide is meant to fill explanatory gaps sometimes left by guides provided by various jurisdictions worldwide, and provide a fuller explanation of the overarching principles required for valid air quality impact assessments. So as we go through the guide, you'll see that it focuses on topics which are not generally dealt with or not dealt with at all in detail elsewhere. So it's meant to be a complementary guide to local jurisdictional guidance. An overarching principle, if not sheer common sense, is that the air quality impact assessment must address the highest air quality levels that can occur as a result of a subject project. This is usually addressed by taking the maximal emissions combined with the worst case dispersal conditions, combined with the highest baseline air quality levels, which we'll talk about a little bit later. If the results become problematic at that stage, then as a particular refinement, one can start to question whether these three factors can be coincidental in space and time. So for example, coal crushing machinery in an open cast mine or at a power plant may emit dust to the environment. The more coal processed in a day, the greater the dust emissions from that machinery. It is important that the maximum emission rates that could happen or will be allowed to happen are assessed. These limits could be set by, for example, facility or plant management, which would be management limits with appropriate oversight, or may be limited by the machinery or process itself in the facility, which would be defined as either production or mechanical limits. There is extended discussion on how to choose an appropriate worst case impact scenario, with the term appropriate meaning either the easiest or more accurate. And the guide also presents refinement possibilities. The guide then steps through the tasks in an air quality assessment, generally in the order that you would do them. Project scoping is usually the first step in an EA or EIA. Scoping the extent of a project involves identifying which project activities would be emitting air contaminants. This should include clear definitions and limits of the subject project or facility, which is the subject of the study, and hence enable ready identification of subject sources of air contaminants in this case. For example, for a proposed coal-fired power plant, it should be clarified if coal mining and coal transportation to the power plant are part of the proposed project. If so, air emissions from those activities must be included in the emissions inventory, and the domain of interest must necessarily be expanded to encompass those activities. Scoping is often a public consultation and leads to the development of terms of reference, or TOR. So in terms of identifying sources, for example, one can question whether transportation trucks used to service a proposed facility would be in or out of the scope of work. In terms of identifying the contaminants emitted from those sources, once the sources are identified, there are various national guides provided. For example, in North America, we have the US EPA AP42 guidance documents. And so the guide doesn't repeat those widely available guides. Jurisdictions may provide screening methods to screen out contaminants emitted at very low levels or insignificant sources of particular contaminants. This may save time and resources by diverting effort from negligible contaminants towards contaminants that may be of significant potential concern. Screening methods would include the use of emission thresholds and exclusion of relatively minor sources of specific contaminants. The use of screening methods tends to be very jurisdiction specific, and so it is important that the proponent confirm the acceptability of screening methods to be used with the regulatory authority. Once all significant contaminants are identified, these are then forwarded to the next stage of analysis. These become the contaminants of potential concern, or COPCs, for an air quality assessment focused on the impacts of the subject facility. Such a definition is important as it dictates the list of contaminant emissions to be considered for associated baseline air quality levels. This is a consequence of the fact that most air quality impact assessments are conducted on a contaminant by contaminant basis. Fugitive dusts are often not dealt with very well, and so are discussed in detail in the guide. Fugitive emissions in general are emissions from general areas and do not emit via definable vents or stacks. And so fugitive dust would include things like road dust and dust from storage piles. So particulate matter emitted should be speciated by size fraction, that is total dust versus PM10 versus PM2.5, which they often are in many of our reviews, but they are not often enough speciated by constituent. A counterexample to that would be metals, which are sometimes earmarked or identified by proponents and regulators, but other minerals, which may have their own health effects, for example, crystalline silica and micas, are often not accounted for. And because species fractionation is often not dealt with well, this topic receives more attention in the guide. Now, the final slide on emissions is on the actual quantification of the emissions themselves. Predictive emission rates can be obtained from various sources. For example, emission rates from jurisdictional advice. Again, in North America, US EPA AP42 emission factors can be used. However, emission factors are not the only predictive emission estimation methods. Other methods include mass balance, for example. Existing sources can, of course, be measured. The guide also provides advice on accounting for spatial and temporal variability in sources and how to ensure worst-case emissions are accounted for in that vein. This is often not well done in many air quality impact assessments. In addition, advice is offered on how finely the temporal resolution of emissions ought to be divided. That is, should they be divided on an hourly, daily, or annual averaging basis? Now we come to the resultant increments in surrounding air quality levels. Of course, these can be measured for existing facilities, or rather, cumulative air quality levels can be measured for existing facilities. For proposed facilities, however, they have to be predicted ahead of time. This is generally known as air dispersion modeling. The choice of models to choose, and there are many models to choose from, is generally set by jurisdiction. So for example, in North America, again, the models AirMod and CalPUF are often used, AirMod being used for simpler situations and CalPUF for more complex situations, for example, where there might be lake or sea breezes. So given all of that guidance out there and the jurisdictional preferences, there's really not much attention at this point provided within the guide. Most jurisdictions also provide fairly detailed advice on the use of appropriate meteorological data, and this guide does not repeat that widely provided advice. But it does go into the ability in most projects to establish weather stations early and thus leave sufficient time to gather enough data to be statistically meaningful, which is widely held to be at least 5 years worth of data. It also provides discussion of alternatives, such as modeled meteorological data from weather models, such as MM5 and WRF. So, Once estimated maximal increments in air quality in the surrounding community are predicted, you would add these to pre-existing air quality levels or baseline levels. Baseline air quality is the air quality level for each contaminant of potential concern that exists before the introduction of the new subject source. Baseline air quality levels, of course, then result from non-subject sources in the area around the facility. Baseline air quality levels can be measured at chosen receptors, but again, you need enough data for statistical validity. For pollutants with annual averages, such as PM2.5, fine particulate matter, you need at least 5 years data to provide statistically representative results. If it's not possible to get that much data over that period of time, the guide discusses some alternatives. The guide also goes into spatial and temporal variations in baseline air quality. Local variations do matter, which means that when predicting baseline levels, regional versus local components of baseline are often separated to allow appropriate level of analysis. And this means that in turn, local components of baseline air quality being emitted from nearby non-subject sources can be explicitly included in the modeling. One of the most important problems in air quality change prediction is the issue of unavailable or uncertain input data. To deal with this, we invoke the principle of conservatism. This principle is based on the requirement to substitute missing or uncertain data inputs with conservative estimates, that is, values that are guaranteed not to lead to an underestimate in predicted air quality levels. There is extended discussion in the guide on this subject, as it is often misunderstood or abused. And there is an example, an extensive example provided in the guide that uses the example of a gravel road in a proposed aggregate pit. In the example used, dust emissions from the gravel road within an aggregate pit are estimated using, in this example, the US EPA AP42 emission factors for unpaved roads. Those emission factor equations in turn use as input silt levels or estimated silt levels. Silt levels on a road are basically a measure of the road dustiness. Since this estimate would be for a proposed site that doesn't exist at present, and for which you cannot take site-specific measurements, you would have to obtain a substitute estimate elsewhere. The data provided by AP42 indicates an upper limit of 16% for silt levels. This would be, using this upper limit would be a simplistic application of the principle of conservatism. Using an average of that data, however, would not generally be considered conservative unless it is explicitly argued that that average value is more applicable to the site in question. The guide also describes some refined alternatives to using upper limits, which include taking a probabilistic approach, and this is explained in more detail within the guide. Of course, once the facility is operational and it does exist, one can take measurements if thought necessary to refine emission estimates if they show to be problematic. Finally, the guide ends on a brief note about evaluating the results of an air quality impact assessment. In many cases, changes in air quality levels are compared to standards as a simple pass or fail test. The resultant air quality levels are lower than the standards, which would be simply thought of as a pass, or they're above the standards, which means a fail, and something else needs to be done before being passed on to the regulators. In addition, the results often have to be passed on to health impact experts, especially in the case of certain pollutants that have no lower limits of effect, for example, PM2.5. Similarly, results may be forwarded to ecological impact experts for a similar type of analysis. So, in summary, the guide provides a number of points. These include that the terms of reference for an EIA should be sufficiently clear and encompassing to incorporate all sources of air emissions to be included in the air quality impact assessment. That the worst case air quality impacts are assessed by considering a combination of maximal emissions combined with worst case or poor dispersion meteorology, that all potential sources of air emissions must be identified in order to fully identify all contaminants potentially emitted, which would be termed contaminants of potential concern. These can include components or species of fugitive dust. Project emissions can vary in time and space, and these variations should be recognized and accounted for. And emission variations over a finer timescale than the respective air quality standard averaging period may be necessary to avoid underestimating air quality impacts. Spatial and temporal variations in baseline air quality levels must be recognized and accounted for. And finally, that assessment input data, if not garnered in a site-specific and accurate manner, may be estimated as long as is estimated in a fully conservative manner or on a probabilistic basis. I must admit I have missed a poll that was meant to have been set in an earlier part of the presentation. However, I think this is probably a good chance to pause for a bit, and we're going to have a poll now. The poll is going to be based on a question that will be posed to you, and it's to identify what your role is. Are you a regulator, a third-party reviewer, or do you represent proponents? So again, the options are regulator, third-party reviewer, or you represent proponents, or none of the above. You can be more than one. I understand that consultants can sometimes be third-party reviewers as well as represent proponents. So flick as many of those choices as you feel appropriate, and we'll get the results of that poll in a few seconds.
So we're going to close the poll, get your options selected in 3 seconds. 3, 2, 1. So we'll close that poll and we'll share the results with you. And so it looks like we have 17% of you said that you were a regulator, 39% said third-party reviewer, 41% represent proponents. So the third-party reviewer and representing proponents are pretty close together, and 23% said none of the above.
Thank you, Bridget. That's very interesting. We have a fairly even spread amongst the different classes of practitioners, and that's particularly encouraging because the guide itself is meant to provide guidance both for proponents and for reviewers. So as you go through the guide, you will see that there's language directed at reviewers as well as at proponents. So, not currently in the guide, but important considerations are the qualifications and/or experience of the practitioner, either the consultant or the reviewer. I'm going to provide some personal thoughts based on my own experience, spanning about 25 years, and expertise. And I would say, if you're thinking of beginning in this area, you should preferably have at minimum a master's in air quality by thesis, as opposed to by coursework, and that this could include professional engineers, but the key requirement is to have that formal research training to understand what is known and what is not known. There are people out there who have an awful lot of experience in the area and do very well without having the masters, and their experience can be just as valid, but it's having that research experience or training that is a key element. Also, I would advise that they should be a licensed professional within the appropriate jurisdiction, which is usually engineers, but can be other professionals. And because those licensed professionals are by law required to place public safety as their highest priority. And if you want to start off in a supervisory position, I'd advise that you have at least 5 years of experience working under another supervisor. I'd like to end up by describing IAIA's role as I see it going forward. And as an organization, we would like to promote the use and adoption of all of our guides, and especially here the Air Quality Guide, and so encourage membership and regulatory authorities to adopt these guides. So for example, I myself am putting forward a proposal to adopt these Air Quality Guides to the Canadian Institute of Mining. If that proposal is accepted, then that becomes a de facto standard for what are called NI 43-101 filings, which mining companies need to make through certain stock exchanges, and in this particular case, the Toronto Stock Exchange, which they need to do to raise capital. So it means that use of this guidance becomes indoctrinated in the way that mining companies would work. So that's my own personal kind of effort on that, and we would encourage others to make similar efforts if they possibly can. In that vein, IAIA also encourages users to become what we call super users of their guides. That is, professionals who are willing to provide feedback to IAIA on improving the guide or expanding the guide, or they will encourage their local authorities to adopt these guides as part of their regulatory regime. There will be an exit poll set at the end of this presentation for those who are interested in becoming super users so that they can register their interest. And at this point, I hand it back to Bridget for questions. Thank you.
Excellent. Thank you so much, Franco, for a great presentation. And we've been having questions coming in nonstop. So please continue to pose your questions. We'll be looking through those. We'll get to as many of those as we can. Our first question, Franco, is from Jayanta, who's asking if you could give a short summary of remote sensing tools and data which could be used for studying air quality.
So in terms of remote sensing, most people think of that as using satellite data to measure air quality levels. It's an area that has good potential because that data is now beginning to be collected on a high temporal resolution basis, hourly or daily, and can provide some good data to support baseline levels in an area where there are measurements. It's difficult to take measurements of baseline air quality, or there has not a good history of air quality measurements in an area. The one thing you have to be careful about is the spatial resolution of the data, whether it is spatially fine enough to give you the types of answers you need for local variations in baseline air quality, which are an important issue.
Great. Another question comes from Mariana. A couple questions actually related to this. How do you select a dispersion model if the local jurisdiction doesn't give any indication to this, or if the jurisdiction doesn't have their own specific guidelines?
So if the jurisdiction does not have its own specific models or guidelines, one can look to international guidelines. Some of the most widely used models around the world happen to be the US EPA models, AirMod and CalPUF. And I'd suggest that you could propose use of one of these models or an appropriate model to your regulatory agency ahead of time to gain their agreement that that will be the model to be used going forward.
Also related to, this is a specific country, but with the trend in the United States toward fewer air monitoring stations, could that increase the reliance on other data sources?
This almost links back to the question on remote sensing. If there are less air quality monitoring stations, it means that your data set is going to be sparser and sparser. And so trying to pick up those local variations in air quality, which are especially important in urban areas where you've got people jammed in very close to quite strong pollution sources, that could help fill a gap. Or you then need to look at, in urban areas, at hyperlocal sampling. So City of London in the UK is doing some really sterling work in sort of high spatial resolution sampling, and there are a few cities also in the US that are starting to do this too, because it's understood that these local variations can be very important.
Joseph is asking if there's specific courses that you know of to improve technical ability to be more proficient in air quality assessments.
This kind of goes back to the slide on trying to get those academic qualifications in air quality. My suggestion that having at least a master's in air quality would be an appropriate way to go. But there also is some thought within IAIA about trying to provide courses or workshops based very much on the guide that we have at present. And so that might come up in the future. But generally, your local university that provides that sort of senior undergraduate or graduate level courses in air quality would be the first place to look.
Anisha is asking what your thoughts might be on using 1 year of meteorological data instead of 5 years for a small island developing state.
So using 1 year of meteorological data might be a valid way to go if you can compare that data to another location which has a longer data set and show it to encompass all of the meteorological variation that you need. So that might be a way of doing it, but ultimately you need to get statistical validity in the meteorological data set that you get that you have to ensure that it encompasses the worst case dispersion that can occur at a particular location. So if you've only got 1 year's worth of data, you kind of have to look around at other methods to try and prove that that will cover all your bases.
Also related to the number of years, we have a question from Kwan about what the basis is for a 5-year data set. Why not 4 or 6, or what's the reason for 5 years?
So that's the minimum amount of time put forward by the US EPA through their Appendix W guidance. That's guidance that's primarily used in the US, but it's heavily relied on in Canada, which is the jurisdiction that I operate in. and it's based upon statistical considerations. So it's ultimately the US EPA's Appendix W that provides that particular guidance.
Franco, we've got a couple of questions about cumulative effects and or cumulative impact assessment, and how is that rolled into air quality?
So the only way that you can really tell if there's going to be a health effect on people or an ecological effect on ecosystems surrounding your proposed facility is by looking at the total exposure to each contaminant. And the total exposure can only be determined by taking the estimated increments caused by your subject facility or subject proposal and adding those to pre-existing air quality levels. So for example, if pre-existing levels of oxides of nitrogen or NOx are known to be at a level X in the surrounding area, and a project will increase those levels of NOx by Y, then you'd have to add X to Y to give you Z, which would be the total exposure levels that people in the surrounding area would likely be exposed to. And that's the only way that you can really tell if a project is going to cause an adverse effect.
Also, you touched just a bit on health. This question relates to health as well. Robert's asking that, considering that ultimately the impact on community health status is the purpose of assessing the air quality impact of projects, why is the analysis by health impact assessment experts left until the end? Why isn't it an environment and health impact assessment as standard procedure? Why is that not proposed by the guide?
Well, I'm not aware of the situations that the question is referring to, but I would think that it should always be done. There are often contaminants that need to be, almost invariably contaminants that need to be, where the information developed by an air quality expert has to be passed on to a health impact expert so that they can evaluate the health impacts, or ecological experts evaluating the ecological impacts. So I would say that that should be happening most of the time rather than in a minority of time. But if the questioner has a specific case in mind, and I'm not sure if I'm answering that case well, I'm happy if they could contact me offline to discuss their particular case further.
Great, thanks for that offer. The next question comes from Stephen. If the only available data in a given area could be gathered by non-official sources, for example, through citizen science projects, could, under the principle of conservatism, the data still be used in any way?
So it sounds like the person asking the question is that the use of data whose reliability is questionable. I think that's how I understand the question. That may not adhere to the principle of conservatism, because if the data being collected is not thought to be fully reliable, then there's potential for underestimate in, say, baseline air quality levels. And so there's potential for underestimate, so it wouldn't really meet the principles of conservatism. But I'm not sure that I quite understood the question. So if I haven't understood the question appropriately and answered appropriately, then the person posing the question can, but I'm quite happy if they were to contact me offline to provide clarification.
Great. Our next question is asking, how do you determine the spatial boundary to be used during an during an assessment? So the spatial boundary, or the domain, the modeling domain of interest, should certainly include all of the subject sources, and also include all of the non-subject sources that could cause local appreciable variation in baseline air quality levels. And the best guidance that I'm aware of is the guidance provided in Appendix W in the US, which provides guidance on how far
away from a subject facility, that non-subject sources should be assessed. So using that guidance is, as far as I'm aware, one of the best ways of trying to set the domains of your modeling boundary.
Indrani is asking, how can we minimize construction dust at different sites? Is there any model of air pollution measurements or impact analysis method?
Dust emissions from construction sites can certainly be assessed in terms of their air quality impacts. And if their air quality impacts are found to be problematic, then there are different mitigation methods that can be applied, such as if you have fugitive dusts, there's the wetting of the surface using watering trucks, for example, or if it's an open air cutting process, cutting bricks, for example, can be a very dusty process on a construction site. So there are different methods that can be used, such as controls on the cutting saw or enclosure. So there are different methods that can be used, and that can lead out of the air quality assessment if it shows the dust impacts to be problematic.
Continuing with the dust theme, for dust emissions from access roads, how much detail should we be expecting proponents to provide? Are there minimum expectations, such as the type of vehicles and trips per day or silt levels on roadways?
So if a proponent is estimating road dust emissions using, for example, the US EPA AP42, there are well-defined inputs into those emission factor equations, and I, as a reviewer, would expect a provision of that input data along with rationale of why each of the inputs would be considered conservative, and so as a result, the resultant emission estimates to be conservative.
What would be the responsible time duration for sampling?
So I guess it depends what type of sampling they're talking about. If it's ambient air sampling for assessing baseline air quality, it depends on the contaminants being measured. But again, the optimal amount of time would be a 5-year period. Many of the contaminants will have annual standards, such as PM 2.5. And in order to collect enough data to get a valid idea of a maximal annual value, you'd need at least 5 years worth of data. But the guide does recognize that there are some situations where you may not be able to get that for one reason or another, and it provides some alternative methods to use data at other sites if they can be considered conservative to substitute in at the subject site.
Perhaps this is what you're referring to, that it covers it in the manual, but this question also relates to that 5-year data. Is it possible to use older or historical data sets gathered over a 5-year period if for some reason, like wars or whatever, that current data is not available?
That's possible, because the 5-year period is just a long enough period that you collect enough data to be statistically valid. It's like an n=5 in statistical analysis type thing. And so it's the length of the period rather than the most recent period, unless you or the reviewer have some concerns about whether conditions around the area have changed sufficiently since that data was collected, or even whether you believe the climate has changed sufficiently from when that original meteorological data was collected to maybe question the validity of that data. But in principle, you can use older data sets if you think they are still valid, as long as they cover a sufficient period of time.
What about country level transboundary air pollution? How can we assess that issue?
So it really is dealt with in the same way that any other air pollutants. It's dealt with air pollutants obviously don't respect boundaries. The difficulty will come in the analysis where if you reside in one jurisdiction trying to get data from the adjoining jurisdiction, there may or may not be some difficulties in that. But in principle, well, on a scientific and technical basis, the boundaries are immaterial because most of the boundaries tend to be political more than anything else. So differing regulatory regimes may come up as a question, but scientifically and technically, transboundaries don't really exist.
Are there any methodologies to assess air quality impact assessment on biodiversity, plants and animals, for instance?
Well, there probably are. This starts to get beyond the scope of the guide. The guide is really on sort of a how to determine resultant air quality levels as a result of a project. And that information then would be passed on to an ecological expert who would make those types of determinations. They would look at, say, resultant SO2 load-ins or resultant acid rain load-ins in a certain ecosystem, and the ecological impact expert would take that data and say, well, it's going to cause this sort of a problem and that sort of a problem.
If a facility is already established, can dispersion modeling be done?
Absolutely. And in some cases, regulatory agencies will demand it, even if you have ambient measurements around the site, which are measuring the cumulative air quality impacts of the existent facility. And that's because unless you have a very long period of ambient air data, at least 5 years, the regulatory authority may question whether the ambient data you have is enough to cover worst case conditions. And so they may actually force you to conduct modeling despite the fact that you have ambient data.
Carl has chimed in just to let everybody know that there is a UK guide on IAQM, and also that there's lots of guidance in the UK on ecology and air quality assessment. And our next question is, sorry.
That's really interesting to know, and I'd encourage whoever made that comment to contact us so we can look at whether we should reference it in future updates of the IAIA guide.
Excellent. Our next question is from Tashana. She's wondering how localized meteorological data should be.
So localized meteorological data should be collected using a meteorological station that follows World Meteorological Organization standards, 10-meter Met tower, wind speed and direction at 10 meters, and so on and so forth, and ensuring that they collect all of the meteorological data that's required as input into the dispersion models. So that the North American dispersion models, for example, AirMod, are designed to take data from standard WMO weather stations. So if your weather station meets WMO specs, then you'll be collecting all the appropriate data that could then be ingested by AirMod, for example.
And speaking of AirMod, can you give an estimate of AirMod model uncertainty?
So the general guidance on uncertainty in AirMod is when AirMod predictions are compared against measured data on a hierarchical basis. So the maximum AirMod prediction is compared against the maximum measured, not necessarily coincident in time or space. There's a ×2 difference between the two. So AirMod could be double or half of the air quality measurements themselves, which doesn't sound terribly accurate, and it's not terribly accurate on a specific time or site basis. But in general, when you look at it on a tiered basis and you use appropriate conservative assumptions, then the key is that it's meant not to underestimate the actual air quality levels. So, you know, it may overestimate to some extent, but that's fine, because then that is protective of human health and ecological health too.
Great. For health impact assessments, wouldn't a worst case scenario or pollution increment cause an overprediction?
In using the methodology that you might be using to provide estimated air quality levels, you might be forced to use conservative input assumptions. So it might overpredict, but you don't know. That's the key reason why you have to use conservative principles. And so it would give you but you don't know. That's the issue. So you only really can get real site-specific data when a facility becomes it comes into existence, and you can take site-specific measurements. So the degree of conservatism is the problem of the proponent. It's not the problem of the regulator. The regulator has to satisfy him or herself that you are not under-predicting. If you overpredict, the regulator really doesn't care. As long as your overpredictions are under the standards, or they meet appropriate health impact assessments, if the data gets passed on to them, the regulator doesn't care. It's only the proponent that has to work through trying to refine their estimates to show that their impact assessments are below the appropriate standards. I'm not sure if I quite answered that one. Again, that could be something where, if the person asking the question wants to follow up with me offline, I'd be happy to explore that further.
Great. How do you determine the distance from the point source of emission during air quality assessment at a road project?
I'm not sure that I really understand the question. The roads are emissions from road sources, such as road dust or tailpipe emissions from vehicles on the road, are usually dealt with as line sources in various models like AirMod and CalPUF. And so those types of on-road emissions would be treated as line sources, which are distinct from point sources. Point sources are usually defined or applied to well-defined vents or exhaust stacks or chimneys. And in terms of determining distances, there are various tools that can be used out there, such as Google Earth or GPS or GIS, in order to determine the distances between different sources.
So do you have any recommendations, Franco, regarding instruments and sampling methods be used to assess the baseline air quality? And specifically, if you could share your opinion regarding using passive sampling methods and state-of-the-art continuous air quality monitoring equipment.
So this is not something that the guide goes into in any great detail, because many jurisdictions provide already a lot of guidance. The US provides many specifications on federal reference methods for air quality sampling for different types of contaminants. And given that there's a lot of the guidance out there already, we didn't feel that at this point there was much point including any of that in here. But in general, if you have to measure air quality and baseline air quality in a way that has scientific certainty, you would generally follow the recommendations of your local regulatory authority. Or if they don't provide any guidance or recommendations, then the US EPA would be a good source of recommendations for how to measure air quality. And these could include passive methods if they have regulatory acceptability, as well as real-time or integrative methods.
What is the recommended way to assess impact from secondary pollutants such as O3 and PM 2.5 from secondary reactions? Are there any impact assessment requirements on GHG emissions?
Okay, so for secondary pollutants such as secondary PM 2.5 and ozone, in general, you need to use the mesoscale models such as CAMEX, and these are going to North American models, which are the jurisdiction I'm most familiar with, that would have chemistry modules included that would mimic the formation of those secondary pollutants, such as secondary PM 2.5 and ozone. The problems with those types of models, though, is that they have quite coarse spatial resolution of the order of about 1 kilometer by 1 kilometer. And then you have to concern yourself with how to look at more local scale variations. So there are mesoscale models such as CAMEX, which can be used to look at regional, more regional pollutants that are those secondary pollutants. In terms of greenhouse gases, as we all know, are climate change have climate change implications, and those are dealt with very different types of models to what we're talking about here and now, where we're just dealing primarily with primary pollutants that have direct health impact and ecological impact. The greenhouse gases, when they're emitted, are usually handled by different types of modelers who look at global climate changes due to increasing greenhouse gas emissions. So those things are modeled, but they're kind of done using very large scale models and in a very different way from what we're talking about in this particular guide. But if that's something that's of a lot of interest to people, then perhaps that's something we need to look at as an organization and see if we need to add on to this guide, or maybe produce a different guide for that, depending on people's interest.
Great, and we have time for one last question. How do you assess air quality impact for natural disasters, such as haze or volcanic eruption emission?
So those natural disasters happen and they increase baseline air quality levels so that the cumulative air quality levels coming from your subject facility would increase even more. It almost becomes a political question or a regulatory question, in that many jurisdictions will allow a relaxation of environmental regulations when there's a disaster or an emergency going on. So if there was an earthquake and there was a volcanic eruption, yes, the air quality levels are going to decrease significantly around the volcanic eruption, but very often on a regulatory basis, the governments take those things into account.
Fantastic. Thank you so much, Franco, for a fantastic webinar. Thank you to all of the participants who have joined us today and posed so many great questions. We did not get time to answer all of them, so we apologize for that, but thank you for participating and for your questions. We do invite you to visit our II webpage. There's a lot of resources on there. Of course, there's the archives of our webinars, and we are working on a webinar program. So once we have some of our future ones up there and ready to go, they will be on there as well. We have additional training through our online professional development program, which does include a mentorship component, and we'll be starting the next one of those in June. May and June, and our annual conference information is up there. Of course, now with the whole COVID situation that was supposed to take place in May of 2020, it will now take place in May of 2021, but it will stay in Seville. So we will have more information as we're getting that organized and put up as soon as we can. So of course, we're disappointed that we couldn't have it this year, but given the situation, we are very pleased that our organizers in Spain are willing to help us to do that, give that to you again in Spain, but just a year later. We have symposia that we've had in the past that have some information, and when we have new symposia, we'll post that information as well. And there's a ton of resources, best practice principles, some short 2-page fast tips that give you the information in a hurry. And of course, our air quality guide is on there as well. So please visit our website to check out some of that information. You will be receiving a link in a few days to the recording and also a link to the slides, as well as the air quality handout. If you didn't get it to download today, or you can't find it on our website, you'll get a notification that it is, you'll have the link to that in the notification. So thanks again to Franco for a fantastic webinar. We had a great response, and we're so glad you all joined us. We encourage you all to complete the survey as you leave. Franco mentioned that there will be a brief poll, and that helps us to improve webinars for you. Also asks for potential topics that you might be interested in, and it asks that question that Franco mentioned about if you're interested in being a super user. So we would love to have you participate in that. That would help us out a lot. So please take a few minutes for that. We know that your time is valuable, and we hope that this webinar was valuable to you as well. Thank you. See you next time.